thank you for coming to hear what I have to say. I think that most people who have come to ISDC conferences have heard me discuss the Mars Direct mission before, and so that will not be the primary topic of this speech. If you do want to know all about it and how the details of how we can get to Mars in our time, I have written a book on the subject, and after the talk, you want to pick one up, you can buy it, I'll sign it. It's a win-win situation. They're $15 even. Okay, but what I'm going to talk about, first I'm going to make some general remarks about the current situation that we're facing in the space program. And then I'm going to talk specifically about an initiative that the Mars Society is launching, has just launched this week, where we hope to improve the situation, perhaps radically. Okay, the situation right now is pretty messy and overall not that good, although there are a couple of promising developments within it. Okay, that is, first of all, if we look at the big situation, NASA, it's a mess. It really is a mess. I mean, you have the one successful part of NASA's Mars program, which is the robotic program, which has been brilliantly successful, and as soon as Curiosity landed, the administration announced that they were cutting the robotic program by 2/3, justified by the NASA administrators saying the program has been successful. So this is little more than a wrecking operation. If you want to destroy a baseball team, you get rid of its best player. And I got to say that the planetary exploration program, particularly the Mars exploration program, is one of NASA's very best players. It's one of the departments that really delivers the goods. And in a time when we're facing an oncoming fiscal tsunami, if the parts of NASA that are delivering are dismantled, it's going to expose the agency to destruction. And this is all the more the case because the manned space flight program is in such a mess. You know, in May 1961, John F. Kennedy committed us to go to the moon, and 8 years and 2 months later, we were there. Okay? And in the meantime, we didn't just get to the moon, we developed multi-stage heavy lift launch vehicles, and a particular heavy lift launch vehicle, the Saturn V. We flew Mercury, Gemini, as well as Ranger and Mariner, and a host of robotic probes. We developed in-space life support, in-space rendezvous techniques, re-entry techniques, in-space navigation, a deep space tracking network, spacesuits, lunar rovers, radioisotope thermal generators, and so forth. Literally the entire bag of tricks, pretty much, that NASA has been using ever since. We're all developed in that period of time. And, okay, and then we actually got to the moon. Now, in January 2004, President Bush got up and committed us to return to the moon. And it is now over 9 years after that. And we're not on the moon. And we didn't develop a heavy lift launch vehicle, or anything, actually. We flew a few successful robotic missions in this past decade, although not as many as they flew in the 60s. But what's the difference? In the past 9 years, NASA spent almost as much money in inflation-adjusted dollars as they spent in those 8 years. The difference is that they had a goal back then. They knew what they were doing. Their activities were not random. And so they did things and they took them to completion. And as opposed to this sort of random method of operation where you do various initiatives, technology initiatives on their own, and you take them forward a few years, but since they're not connected to anything, since they have no definite purpose, they then always get canceled before they ever reach flight status. And this is the situation we're faced with right now. But the SLS, this Space Launch System, or Senate Launch System, as some people call it, It's a reasonably good heavy-lift vehicle, but it's being developed without any payloads for it to launch. So what is it going to be used for? 4th of July displays? Okay, and in an environment where you have the budgets being cut, and at a certain point someone's going to ask, why are we doing this? And that program will end without ever delivering a heavy-lift launch vehicle. The Orion capsule, it could be used to send people to the space station, except that it's too big to be launched on an Atlas, and for launching on an SLS, it would use 1/4 of the payload capacity, so it's neither fish nor fowl. There's no launch vehicle that is appropriate for it. You could use it, I suppose, to do a mission like the Inspiration Mars mission, because the SLS could throw that on a direct trajectory to Mars, and if the SLS had an upper stage, which it should, but currently doesn't. You could use it for missions of that type, but because it hasn't been designed as a coherent part of a mission architecture, it's designed with its own set of requirements that don't fit. The Apollo hardware was designed as a set. In other words, we didn't do Apollo because, one day in the mid-60s, 3 guys happened to run into each other in the cafeteria at Marshall and said, with your Saturn V and my command module and his lunar ascended descent vehicle, if we put all this together, we could send people to the moon. Do you realize that? No. What happened was they had an imperative to send people to the moon, and then they realized they needed these different pieces, and that they all had to be designed to fit into a coherent mission architecture, and they did, and they were able to do lunar missions. And that's what we're lacking right now. I mean, the Bush Return to the Moon initiative, frankly, was not my favorite. I think we should have, in 2004, had set a goal of sending humans to Mars by 2020, not to the moon. To send people to the moon a half century after we were there the first time seems to me to be unworthy of NASA as its primary goal. You could do that as sort of a secondary thing, like flying John Glenn on the shuttle was sort of a fun thing to do, but we didn't have a shuttle program in order to do that. But even so, it wasn't my favorite. At least it was a goal, and if it had been embraced, and by the way, if it had been really embraced, President Bush wouldn't have gotten up in 2004 and saying we should be on the moon by 2020. He should have said we should be on the moon by 2010, because it only took 8 years to do it the first time, and they had to invent half of it as they went along. Okay, I mean, at the time that Kennedy committed us to the moon, we didn't even have push-button telephones in this country, let alone, this, and so forth. But precisely because, by the way, the Bush initiative was not pushed with the kind of vigor and determination as Apollo is why it failed. Because, and it was predictable, and I actually met with Mike Griffin in his office in 2005, shortly after he took the helm, and laid this out. I said, look, on January 21st, 2009, all this is going to be not invented here, and unless you're practically to the moon by that point, this program is going to be canceled. And in fact, the Apollo landing on the moon would not have happened if Kennedy had said, let's do it by 1980, okay, because the Nixon administration, elected in 1968, was unsympathetic to their program, and they only carried through on it because it was practically there at the point he took office. Okay, and so in other words, if you want to go to Mars, you can't do it in 30 years. You can't do it in 20 years. You have to do it in 10 years or less from program start, or you're more or less guaranteed the program will fail because the political consensus that launched the program will no longer exist by the time it comes time to do it. So, about a year ago, I was invited by a NASA bureaucrat who wanted to create some cover for their destruction of the Mars program to take part in a study of a human Mars mission to be done in the year 2047. And I said, did you just say 2047? And he said, yeah, 2047 would be a real good year for a Mars mission because it's one of the best years. I said, did you just say 2047? express my views on the subject with great tact. So this is a mess, and I have to say, this thing we have now, okay, you know, we had the moon program, and then a year after taking office, the Obama administration cancels it. They said, well, we're going to go to a near-Earth asteroid. Okay, that's better, because at least it gets us out of geocentric space. And, well, okay, there's some merit to that, going to a near-Earth asteroid. It does get you out of geocentric space, and frankly, you could do it with a subset of the hardware that you would use to go to Mars. So, fine. But then a year later, they changed their mind and say, nah, we want to build a space station at L2. And then a year after that, they say, no, what we're going to do is we're going to move a rock. They call it an asteroid, but it's a rock with a radius of 10 feet, so it's not actually an asteroid. Okay, that's called a rock. Okay, to a kind of a lunar-like orbit, and then astronauts will be able to visit it and do the asteroid mission without having to leave geocentric space. Okay. Well, actually, astronauts can visit those kinds of asteroids without leaving the Earth by visiting the American Museum of Natural History, for example. And since the entire point of the asteroid mission really was to get us to take that leap, and instead of just doing 3-day missions to the moon, you're taking 6-month or 1-year missions into heliocentric space, and test out our ability to travel in interplanetary missions. This negates it. Okay? And I must say, all the other rationalizations that have been advanced for this so-called asteroid capture mission are also fallacious. It's not the right way to do asteroid science. For the much less money, you can collect samples from a lot of real asteroids using robotic spacecraft. It's not the way to do planetary defense, okay, with electric propulsion, because a real asteroid would weigh about 1 million times as much as this thing, and it would take hundreds of years for the kind of electric propulsion system that is being discussed to deliver a delta V of 1 meter a second to such an asteroid, which is about what you would require to deflect it from hitting the Earth if you did it right. Okay, so that's not going to happen. The right way to deflect an asteroid is to implant high explosives, either conventional or nuclear, depending on the size of the asteroid, and blow a chunk of it off of its side and deliver a sudden impulse to it at the right part of its orbit, okay, which this won't do, okay, and it doesn't get us out of geocentric space, so it negates the purpose of the real asteroid mission. So it's not planetary defense, it's not science, and it's not space exploration. And it's not resource utilization either, because, if you have this object over there in this sort of retrograde lunar orbit, it's not in the right place for anything. For instance, even if you could make oxygen out of its 5% water content, which would be a trick because you have to do all this processing and everything, it would take you as much delta V to reach this object from low Earth orbit as it would take you to go to Mars from low Earth orbit. So even if this thing was sitting there right now with liquid oxygen tanks sitting on the surface, available, to be given for free to anybody who would drop by, it wouldn't make any sense to make use of it. So this is not a useful initiative. And I think this is just so scatterbrained that, well, first of all, I doubt very much that this initiative will be the initiative for more than another year or so, and then they will be forced to switch to a different subject, and so forth. And if you have NASA drifting this way, under, as I say, conditions of an oncoming fiscal tsunami, if NASA doesn't know what it wants to do, and people come and say, what do you need money for, then I think the agency will be defenseless. And so I think it's very bad. And there are people who say, oh, well, we got to do space privately, goodbye NASA. And I would prefer to have both public and private initiatives going on to help get us into space. Look, there's 190 countries on this planet, and at least 180 of them have no government space programs to speak of, and it's not like they're launching major free enterprise space programs. Okay, so, almost all the technology that the private space initiatives are using were developed by government space programs in general and mostly NASA. I don't want that to go down the drain. So somebody has got to provide a lead here. Somebody's got to provide NASA the vision. Now the mission that's been staring NASA in the face since 1969 has been humans to Mars. We accomplished the first step in the Moon Valley. We did reach the moon, okay? People say we should go to the moon before we should go to Mars. I agree, and we did, okay? But now it's time to do more than what we did more than a generation ago. But NASA seems to be searching for a way to do anything but that. Okay, well, okay, we've had some hope now coming from private initiatives. Okay, and two very well-known ones at this point are the Mars One and the Inspiration Mars. Of the two of them, I mean, of course, Mars One would be extremely exciting if they could pull it off, but it's extremely ambitious. I mean, there's nothing in it technically you can do, but the amount of resources required to do it so far are not apparent among the group that's pushing it, although they now have some resources because they just raised $3 million, but they need a lot more than that. The Tito mission, on the other hand, the Inspiration Mars, is quite a doable thing. I actually proposed a two-person Mars flyby mission to Dan Golden in 1995, and we had costed that out at about $2 billion, which certainly is within NASA's means, and could have done, and it would have been done by now had they embraced it, but Golden did not. Now, he said, well, what science are you going to get, what this, what that? And, of course, the science you get from it is marginal, but what science did Lindbergh get, you know? I mean, what payload did he deliver across the Atlantic? How many passengers did he deliver? No, the purpose of the Lindbergh mission was to show that you could do it. The purpose of a two-person Mars flyby mission is to show that you can do it, to remove these dragons from the maps of interplanetary space and show that this is a doable thing. And, you know, because, you know, even though NASA has data, they have it from Marie and they have it from RAD, that shows that the cosmic ray dose in interplanetary space is only a factor of 2 greater than what it is in the space station, okay? Which means that, by the way, the crews they're going to send to the space station over the next decade will accumulate as many man-reds of radiation as they would have gotten had you sent 5 crews to Mars on every other year over the same period of time. Okay, because the Mars crew spends less than half its time in space. 60% would be spent on Mars, doses lower. But even so, even though that data is there, even though there are cosmonauts who have spent over 700 days in space cumulatively between the Mir and the ISS, and therefore have accumulated cosmic ray doses equal to what they would have gotten flying to Mars and back, and we've seen no radiological casualties among this group, they're still holding back. There's a psychological barrier, and the Inspiration Mars mission would break it. Furthermore, if the Tito group is successful with Inspiration Mars, they would gain a lot of credibility, so much so that they could probably then mobilize the much larger amounts of funds and resources needed to fly people actually to Mars. And then if you could do that, you'd be able to raise the resources needed to do one-way missions to Mars. I mean, look, the ironical thing about our movement, about the space movement, is that we actually have the resources to do everything that we want to do, but we can't seem to mobilize them. I mean, think about it this way. There's 7 billion people on this planet, of which 1 billion or so live in the advanced sector, in the countries where people have money that they can spend on things that are not the bare necessities of life. And of those billion people, certainly at least 10%, and I think probably more like 20 to 30%, believe that it is fundamental to a positive human future that humans expand into space. So we've got 100 million people who think like we do. 100 million people. 100 million people times $100 a year would be $10 be enough to fund a program to explore and settle the solar system if spent in the private world. So the question is the harvest is plentiful, but the gatherers are few. It's like having an army which is spread out over a battlefield, which has more than enough force to win the battle, but the soldiers are all confused and demoralized and don't know they have enough force to win the battle, and so they're just a helpless mob, and they're easily defeated. It's a question of morale. If we could rally the forces that we have, we can win this, okay? And, it's just a question of raising a flag high enough to rally all those troops into a coherent force so they can then proceed to victory. Okay? So, it's my hope that one of these projects, such as Inspiration Mars, or perhaps Mars One, if it can get more resources and then adopt a similar incremental strategy where they first do something real and then that will give them more credibility to something ever more ambitious, to create this kind of force. And by the way, that's what you want. If you want to do one-way missions to Mars, you don't do them as a one-off. You have to create an organization, a funding base that could sponsor the colonists and they would know that there are more people and more equipment and more supplies to follow behind them. And by the way, this is how colonization has typically been done in the most noteworthy episodes, or many of the most noteworthy episodes that one can name. For example, the Pilgrims coming to Plymouth, or the Mormons going to Utah, or the Jews going to Palestine. In the 20th century, there were always large home-based support organizations that provided the funds to help finance the actual colonists to go where they needed to go, and to make sure that they continued to have support until these things were strong enough to stand on their own. And that's what we want for Mars. So those are the most hopeful developments, and of course, should the Inspiration Mars mission happen, okay, and we show that this cosmic ray situation is not so prohibitive, and so NASA can stop saying we can't go to Mars until we have warp drive or something, okay. NASA administrator, by the way, gave a speech a month or two ago where he said they were working on faster than light travel. So once they have that, then they'll go to Mars. Once we get out of that confusion, then perhaps we'll get leadership at NASA that is able to put it straight to the president and say, look, we can have people on Mars in 10 years if you give us what we need. Okay. So, I think that people should support these initiatives or launch one of your own. And the Mars Society intends to do both. In addition to basically continuing to say that NASA needs a goal, and the goal should be humans to Mars, and that we should have a space agency that is committed to going somewhere, and so on, saying how do we help raise the public appreciation for that? How do we help put Mars as a goal in front of the public? How do we help show the value of people on Mars to the public? And it is to do this that we, this week, launched an initiative that we call the Mars Arctic 365 mission. Okay? And in brief, what this is going to be is we intend to send a crew to our Mars Arctic Research Station on Devon Island for a one-year mission. That will include staying over the winter in the Arctic. Okay. You've all heard, of course, of the Mars 500 mission. And this was a valuable exercise, and it attracted worldwide attention. But it must be said that the Mars 500 mission were with people sitting in a room in Moscow, okay, and they experienced a certain kind of isolation, but they were not under any kind of mission stress, either in the sense of needing to get real work done, dealing with bulky equipment, dealing with danger, dealing with discomfort, dealing with anything, okay? But we intend to deal with all of that. Okay, so let me talk a little bit now about the Mars Society's analog research program that has been going now for some time, but which this initiative will now take to the next level. Okay, so the Mars Society was founded in 1998, and we decided we'd do three things. One was brought out once just to spread the vision. The second was political work to try to defend and advance the Mars program in the political sphere. And the third was to launch projects of our own, of which the first was to create this Mars Arctic Research Station on Devon Island, okay, which is 900 miles from the North Pole. It's the largest uninhabited island in the world. It's a polar desert with a meteor crater on it, 20 kilometers in diameter. The meteor impact occurred about 23 million years ago. It has created shock terrain in the polar desert and geology that many scientists think it may duplicate that which exists on Mars, and therefore NASA scientists have been up there quite frequently to explore and to try to learn about the geology of Mars through geological analogs. We decided what we would do was build a Mars station there, not so much to learn about the geology of Devon Island, but to learn about the exploration process itself by trying to explore the geology and other phenomena of Devon Island while operating under Mars mission constraints. And the analogy that I use is like target practice. The purpose of target practice is not to put a hole in the center of a target. Okay, you could do that very easily by putting the target on a table and hitting the center of it with a screwdriver. Boom, okay, bullseye every time. The purpose of the target practice is to put the target out at a distance from you and then put holes in it at its center, not for the purpose of making holes in the center, but for the purpose of learning how to shoot. And so the idea of attempting to do sustained field exploration while operating under the constraints of Mars missions is a way to learn about how to explore on Mars. So we built the Flashline Mars Arctic Research Station. It was built entirely on private money, and that's why it's called a Flashline Station, because Flashline.com bought the name. And we had other money from the Discover Channel, and as well as a very large number of private donations from my membership. About half the money came from major donations of 100,000 class, and the other half came in small donations of $100 class money. Okay. So, you know, you get this crew up there, and they're not allowed to go outside to do exploration, except when they're wearing these simulated spacesuits, and they do a number of kinds of activities. Okay, as you can see some of them here. There's direct field sampling, there's deployment of instruments, in some cases rather complex instruments in the field, exploring in methods of field mobility, decision-making processes. Okay, and so, you know, for example, in instrument deployment, you start to find out real fast about what instruments you can use when you're wearing a spacesuit. Even our spacesuits are not as bad as real spacesuits. Nevertheless, you wear these thick, heavy ski gloves, and if you have instruments with delicate little buttons and stuff on them, they're very hard to use. Or screens that reflect the sunlight in a way that makes it hard to read a computer screen. This is a problem. Field mobility, we have found that you know, there's different visions for field mobility. Do we want to use pressurized rovers the size of SUVs or even the size of RVs? We have found that the most useful systems for field exploration are the small equestrian systems like all-terrain vehicles. They give you a much more informal relationship to the environment. If you see a sample, it's not a question of going EVA out of a pressurized rover. You're already in your suit. You just lean down, pick up the rock, look at it, and decide whether you want to sample it or toss it. Okay. And also, when they get stuck, one or two people can lift them out of their impediment. Whereas, of course, a large pressurized rover would be a real problem on Mars. There's no AAA to pull. And so my view on rovers is if you can't lift them, don't bring them. We've had situations in dealing with some tough situations. In the crater of Devon Island, there's quick mud, and we had a situation where a trailer went right down. There was a crust on top of the mud, so it appeared to be dry soil, but we were driving on it, and the trailer went through it, and then we had to get out and try to retrieve it, and this was very tough. There were some interesting interactions here, by the way, because if you look at these two pictures, who filmed this? It was a human factors scientist from NASA, was filming me and this other fellow, the person who's doing the talking in the picture on the upper right. That's Vladimir Pletser, he's from the European Space Agency. He and I were trying to get this thing out, while this other fellow, who you see in the image between me and Vladimir, is Bill Clancy from NASA Ames. And Pletser was really pissed at Clancy. You know, we're here, we're struggling with this thing. I mean, you know, we're waiting and quick, like, this stuff would be absolutely deadly, except for the fact that about a meter down there's frozen permafrost, so there's finally a hard surface that you can walk on. But anyway, we're struggling with this, and you're standing there filming us, and then Clancy is saying, so you're feeling anger. Okay, which, by the way, I suggest that you should not bring human factor scientists with you to Mars. Because believe me, he would have been out the airlock. Okay, now, okay, and in fact, you shouldn't bring any scientist whose goal, whose primary mission is to study the other crew members. Bad. Okay, field navigation. We found the need to use electronic field navigation. Devon Island's a desert, and a lot of it can really look the same, especially to relatively untrained eyes, and you can get lost. And some people who know military history may know that in World War II, entire regiments were lost in the North African desert and just ran out of water and died. Okay, and this can happen here too. So you do want to have some form of electric navigation. Now, of course, on Earth we have the GPS. To create a GPS system for Mars would be wonderful, but probably it's an excessive demand. But a system of beacons, radio beacons, landed could be used to support effective field navigation. Communicating with the field teams. Initially, in our sims, we had someone constantly communicating with the field teams, kind of like you saw with Apollo. Over time, we decided this was unnecessary. You don't have to have the field teams constantly reporting back. We are now 40 feet from the rock. We are now 30 feet from the rock. We expect to soon be 20 feet from the rock. Basically, we found that them simply reporting in every half hour to give us a status on their condition and location was quite sufficient to save everyone, both them and us, a lot of time. Okay, crew recreation. And other human factors issues. The classic book on exploration psychology is Bold Endeavors. The name escapes me at the moment. But it's a pretty good book. But with respect to Mars missions, I think it's wrong. And I'll tell you why. The book Bold Endeavors is based on studies of the psychology of U.S. Navy crew members at McMurdo Sound in Antarctica, and they don't want to be there, and they're bored. And he says the primary problem with these isolated groups is boredom. We found the primary problem was overwork, because our crew members are not made of Navy enlisted men who would rather be here in San Diego on the waterfront, but it's made of scientists who want to be there, out there doing their life's work, and they are driven, and I would have to repeatedly order people to stop work at 9 o'clock at night, or else they just burn themselves out, they just keep going. And then get the crew down, and then we watch a movie or something together, and what we found almost universally is the favorite kind of movies was light stuff, comedies, and for instance here you see we're watching Mars Attacks. Okay, and then the crew has to deal with its lab work, its equipment repair, instrument testing, and I would say the most valuable people we have found in the mission are people who are good at fixing things. That's really should be the most, if I have 4 people on the Mars mission, I want 2 of them at least to be, their primary qualification is as flight mechanics who are good at fixing anything. That they are the most valuable players on the mission. And then after that, the field scientists, who are the intellectual drivers of the mission, who set objectives and define coherent work for the crew to accomplish. Then experimenting with tactics for exploration. Okay, there's things, ultimately, it's about bringing the geologist to the rock. Okay, and there you have it. That's the most basic thing. And there's Nell Beadle up there in 2002 with her rock hammer, and she's an experienced prospector-type field geologist, and she's the kind of person who went on Mars. But you'll probably want to have her operating in a telescience collaboration with a large back room on Earth containing all the geological specialists. And this is a technique that needs to be developed of what we call telescience. It's analogous to telemedicine, which is not how science is done on Earth today, but is how we want to do it on Mars. Okay, then here you have supporting remote exploration. Here we're taking ground truth measurements for a JPL remote sensing satellite. Combined human-robot operations. You can think of a Mars mission as a combined operation, analogous to military combined operations, where they have infantry and tanks and helicopters and aircraft and satellites, and all these different things that have to be combined to create the most effective force. Well, similarly, in a Mars mission, you'll have pedestrian astronauts, you'll have motorized astronauts on vehicles, you'll have robots, you'll have perhaps drones, you'll have satellites, you'll have the team at the hab, you'll have the remote science team back on Earth, and you have to make all these things work together. And this is an art of combined operations that needs to be worked out. Okay. The role of physical activity. One thing you discover when you do these mission simulations is that Mars exploration is a physical activity. It's not an extreme activity like climbing Mount Everest or something, but it's quite physical. Hiking is like heavy-duty backpacking, and hiking around in these spacesuits is quite physical. And so it's apparent if you do this, for instance, that the NASA Space Medicine program right now is totally off base. They're solving the wrong problem of how to keep people alive in zero gravity. You don't want to go to Mars in zero gravity. You want to go to Mars in gravity, because the issue is not simply preventing the crew's bones from thinning out. It's having them be in top physical form to do this kind of activity when they're there, because the amount that they're going to be able to do will be directly proportional to their physical condition. And so there you have it. And we've done many human factor studies, some of which have been quite relevant and others quite irrelevant. This one up there, the aptitudes, is we're taking to see if they can predict who could be the best rover operators based on certain tests. That was useful. It was somewhat predictive. This other thing sent to us by NASA, which posters did people want for their rooms? Silly. And especially since whenever we've had a good crew, people did not spend their time in their rooms at all. They spent their times together out in their rooms, interacting. Special skills. This woman here, she was a chemist, and that's why she was on the mission, but she was also a very skilled pianist. And we had this little electric piano up there in the station. And even though we had CDs and whatnot you could play, that they could play in the recorder, she could get out this thing and bang out Mozart. It was really a lot of fun. And so it wouldn't be a bad thing to have a musician on the Mars crew, not as their primary assignment, but there. Now we've also built the Mars Desert Research Station, where we've had a lot more crews, typically 2-week missions, though there have been some 1-month missions there. At this point, we've actually had 130 crews at the Mars Desert Research Station. And we're getting a lot of data, and we've had, between the Arctic Station and the Desert Station, we've had 140 crews. Okay, that is over 800 people have served in one crew or another. 800, okay, and 200 or so in mission support. 13,000 person days of crew time. People from lots of countries, and including NASA and ESA personnel, as well as university people, industry people, all kinds of people And, you know, human factors data is very interesting. If we had a single crew, people say, well, you're doing 2-week cruise at the desert station, typically 1-month cruise at the Arctic station. The Mars missions are going to be longer than that. That's true, and that's one reason why we're about to do a much longer mission. But nevertheless, the human factors data, you can get much more of it with a larger number of crews, because, you know, what personality types work best in the Mars mission? Well, it's an interesting question, because we've had situations where we had particular individuals who served with great distinction and were real strong crew members in one crew, and who were disasters and wreckers in another. And it's a question of the chemistry. And you gotta look at this. I mean, we've had all kinds of crews. We've had all men crews, all women crews. We've had mixed crews of every proportion. We've had international crews and national crews and so forth. We've had all American crews and all German crews and all Australian crews. And crews with one person from each country, and Russian crews and so forth. And we've had crews of different age distributions and so on. And I mean, we're getting data over time, but it's hard to make complete generalizations on this. I would say, though, that there are a number of conclusions that we can draw already from this program. Okay, first of all, the physical nature that's up front. Okay, you want artificial gravity for Mars missions. The key human factors problem is overwork, not boredom. Crew time is a precious resource. Okay, you know, before we did this program, I'd go to some workshops, and there'd be some NASA people there, and they'd say, well, we got this cool telerobot which the crew can use when they're not doing anything, and this will stop them from being bored. Believe me, the crew doesn't need people to think of ways to occupy their time. Their time is oversubscribed as it is. You want the mechanic is the most valuable player. Crews should cook. Okay, the station is stocked mostly with shelf-storable ingredients: rice, beans, flour, pasta, all kinds of sauces, can this, can that. But with imagination, you can make interesting meals out of various combinations of this. And we would cook dinner every night. And initially, I thought this would be a chore that people would want to avoid. So I simply said, we'll simply take turns. And that worked fine. In fact, it developed into a competition of people competing to see how they could create something interesting out of all this. And then you get everybody to sit down together for a meal, and it's a bonding thing. And on the other hand, MREs, they get old. Crews should operate on a common schedule, not watches, and certainly not free cycling. Free cycling is when everybody just wakes up and goes to sleep on their own. Robust instruments are better than fine instruments. We have this terrific ultraviolet fluorescent microscope at the Mars Desert Station for a while, but then after 6 weeks it became non-functional, whereas a crude optical microscope like college students use, it's just a workhorse. It's been there for years and worked great. Small vehicles are best, as I've said. Electronic navigation is necessary. The hab should be power rich. You don't want to have a situation where you have to turn off 3 things in order to turn on another thing, and then you're running something, and then somebody turns on their computer and the fuse blows out. You can't have that. The physical chemical waste recycling is better than bioregenerative. We've tried both. Let me tell you, bioregenerative waste recycling stinks, literally. Okay, because the bugs do what they want to do, not what you want them to do. The mission needs to be led from the front. Okay, so we don't even call our mission control anymore mission control. We call it mission support. The crew has to be commanded by the crew commander. Science effort needs to be led from the front. We need telescience as a new art of doing science. Independent robots are completely obsolete once crew is there. Humans can do on-the-scene exploration 1,000 times faster than independent robots. However, small robots as auxiliaries to the crew are quite useful. For instance, to go into caves and crevices or to lower them down cliffs and so forth. And then also water use. This is a big issue, water use. How much water do you need? Well, you can look it up in a medical textbook, and it's about 1 liter a day, but that's not the water that you use. You use much more water for washing and for cooking in, for all sorts of functions. Now, if you look at the amount of water that you use on your water bill, it's a fantastic amount, and it's absolutely intolerable on a Mars mission. NASA has come up with estimates of 32 liters a day per person. And then if you could recycle that at 90%, that would be 3 liters a day per person, but that's still a lot. So we looked into how can you limit water use? Well, do you need showers every day? No. What about every other day? Okay. Why showers? Why not sponge baths? Okay. It's like sponge bath every day. Why not every third day? Why not once a week? Okay. So how far can you push this? It's not an absolute question, it's a relative question, because it's a trade-off between mass and morale. We found that by doing sponge baths every other day with a Navy shower, which is a very brief kind of shower, once a week, that was adequate to maintain crew morale, and under those conditions you could limit overall water use to 12 liters a day. And then with recycling, that's 1.2 liters a day, and that gets the mass budget under control. So, okay. Now, this kind of analog program, a lot of the research that we're doing up there is not with the same technologies you use on Mars. For instance, our all-terrain vehicles, our conventional gasoline-powered all-terrain vehicles that would not work on Mars. Okay, but nevertheless, they're analogs for vehicles that could work on Mars. And before you decide whether you're going to build a one-person all-terrain vehicle, a two-person all-terrain vehicle, you know, a motorcycle or a pressurized rover or a pressurized RV, you ought to decide which one of them you actually want, you know, that will work on a methanol oxygen fuel cell or something, but which is the right vehicle. In other words, really the most important step in engineering is defining the requirements. Or put it more simply, it's the most important thing in engineering is not to design things right, but to design the right thing. Okay? And that's what we can figure out with this sort of thing. So, to get us now to the Mars 365 mission, we want to do one more mission. This is a much more difficult thing than we've done. So far, the longest mission that we've done at our Arctic station has been a 4-month mission, which began in April and ran through August of 2007. And that was successful, and it was tough, but we did it. But the thing there is you have daylight the whole time. And that's a very good thing. And while it's pretty cold up there in April, it's not that bad. And then in summer, it's, you know, acceptable. Now what we're talking about doing is a year-round mission at the Arctic station. So it'll be 12 months there, including about 5 months where there'll be no sunlight. Okay, there'll be sunlight from the northern lights and so forth and other things, but but not, the sun will not be above the horizon for 5 months of the year, and it will be very cold, so there's no solar power. The power's either all diesel or wind. The crew will be pretty isolated. I mean, there is the capacity to effect rescue with twin otters out of Resolute Bay, but not necessarily today. They come when they can come, and the weather can make that intermittent. So you'll deal with the isolation here, and the danger that goes with isolation. Not by being in a room in Moscow, but by being out there, and simultaneously being tasked to do sustained programs of field exploration in geology, microbiology, climatology, and during the winter, astronomy. We'll be able to do from up there. The crew will have to deal with bulky equipment and fix it themselves under rough conditions. They'll have to deal with the discomfort of this sort of situation. And yes, under those conditions, they'll have to deal with the human factors issues. And, you know, the human factors problem of a Mars mission is not, oh, will people go crazy because they're isolated for 2 years? I mean, no, if you pick people who are of average psychology or better, they're not going to go crazy by being isolated for 2 years, okay? But it's a question of, can they work together effectively as a team? Do you have a healthy dynamic in the team that can be sustained to make that then be a one for all for one team that really gets the job done and doesn't undercut each other, sabotage each other, and really pulls together and pulls the mission off, despite all these stresses that will be making things more difficult. And that's what we're going to do now. But, as you know, the Mars 500 mission got worldwide attention, as it should have. It was worthy. This is going to be a lot more worthy. So we think that this mission will put the vision of humans exploring on Mars before the entire world in a way that simply hasn't been done yet. We think this will gather worldwide attention and draw people to the visions of human explorers on Mars. And should we do this? Yes, it's my hope that this will also bring us the resources to do still more ambitious things. Okay? And that's what we intend to do. This mission is now, it's divided into 2 phases. Phase 1 will occur this summer. We've gotten the free loan of 2 aircraft, Kodiaks, that are capable of Arctic operations, and their pilots, and their fuel, to support an expedition to Mars this summer that will go up there and deliver a lot of equipment and do a refit to the HAB to greatly reinforce its insulation, to create a heating system where we take the exhaust from the diesel generators and use it to provide thermal heat to the HAB, which is needed in the winter, it's not needed in the summer, and a multitude of other improvements. This is now funded, this is going to happen. This mission takes off in July, and it's going to be led by Joe Clay, who some of you may know. Sort of been the leader of the 4 Frontiers organization. The issue then of the Mars Arctic 365, the 1-year mission itself, that will then happen beginning in the summer of 2014, assuming we can raise the funds, which we are now actively soliciting. So that's where we stand. Thank you, and I'll take questions.